All right, welcome back, Year 12s. So last lesson, we put together the skeleton of our hangman game, right? Well, today, we're giving it a brain. This is all about designing the logic, the engine that's going to make the whole thing tick. And the best part, we're doing all of this before we even think about writing a single line of code. So here's what we've got on the agenda. First, we're going to talk about why you should never code without a plan. Then we'll dive into the algorithmic blueprint itself. After that, we'll look at the building blocks of logic, some specialized tools like functions, and finally, we'll put the whole hangman plan together. Sound good? Let's go.
Okay, first things first, let's talk about something I know you've all been tempted to do. It's a huge pitfall, and honestly, learning to avoid it is pretty much the key to succeeding in this project.
So let's be real for a second. Have you ever had that feeling, that urge to just fire up your IDE, open a blank file, and just start smashing out code without any real plan? Yeah, I see you nodding. But that urge, it's a trap. It's an absolute recipe for disaster. You get this chaotic, messy code, bugs that are just impossible to track down, and you just waste so much time. This is exactly where that learning muscle we're focusing on, resilience, comes into play. It takes some serious discipline to step back, resist that temptation, and actually map everything out first. But trust me, it's worth it. So, if just jumping into code is the problem, what's the solution? Well, it's all about creating a blueprint, an algorithmic blueprint. And, getting this right, it ties directly into that SC1102 outcome we need to hit. The one about understanding how these structures actually build a real working program. So what even is an algorithm? Don't let the word scare you. At its core, it's just the plan. Think of it like a recipe for a cake. It's a super clear, step-by-step set of instructions that tells your program exactly what to do to solve a problem. That's it. And for this blueprint, you've got two main tools in your toolbox. You've got pseudocode, which is basically writing out the recipe in a simplified code-like English. And then you've got flowcharts, which are awesome because they give you a visual map of the whole process. And you're going to need to get good at both of these for your assessment, for sure. And look, if you need a little extra motivation to really nail this planning stage, how's this? Your flowchart, if it's detailed and logical, is worth 5 marks. 5. And that's because it's not just about drawing pretty shapes, right? It's proof that you can think logically, like a programmer. Getting this blueprint right isn't just a step, it's the foundation for everything else. Okay, so we know why the flowchart is so important. Now let's get into the how. What are the actual building blocks you're going to use to put it together? Well, it all comes down to the 3 fundamental control structures of programming. And this is pretty wild when you think about it. Literally every structured program you've ever used, from the calculator on your phone to, a massive operating system, is built using just 3 basic ideas. You've got sequence, which is just one step after another. You've got selection, which is all about making choices. And you've got iteration, which is just repeating stuff. That's the whole shebang. Let's zoom in on selection. This one is purely about making decisions. It's your basic, if this happens, then do that kind of logic. It's what lets your program be smart and react differently depending on what's going on. Okay, lean in for this one because this is the golden rule of flowcharts. Seriously, tattoo this on your brain. Anytime your logic needs to branch, anytime there's a decision to be made, it has to go through a diamond symbol. No exceptions. This is a NEASA standard, so it's non-negotiable. You gotta get this one right. And you can see this perfectly in our hangman game, right? You're gonna have an if/else check. If the player's guess is correct, then you do a bunch of stuff. Else, if it's wrong, you do a different bunch of stuff. That's selection right there in your project. All right, next up is iteration, or, repetition. To be honest, this is the secret sauce. This is the magic that makes a program feel like a game. It's the loop. It's what lets the player keep guessing over and over and over again. Now, for our main game loop, we're going to use something called a pretest while loop. And the pretest part is super important. It means it checks the conditions before it runs the loop each time. So it asks, hey, is the word guessed yet? And does the player still have guesses left? As long as the answer to both is yes, the game continues. The second one of those conditions becomes false, boom, the loop stops and the game is over. Okay, we've got the basics down. Now let's level up and talk about a special tool that's going to keep your code super clean, efficient, and easy to read. let's talk about functions. I want you to think of a function like a highly trained specialist you hire for one job. You hand it a task, it goes off and does that one thing perfectly, and then it comes back and gives you a single specific result. And that little piece of information it gives back, that return value, that's the key thing that makes it a function. So it's always this simple three-step dance. Step 1, you send some data to the function. Step 2, the function processes that data. And step 3, it returns one single value back to you. A perfect example would be a function to update the score in your game, right? You send it the current score, it does the math, and it sends back the new score. All right, let's bring this all home. We've talked about all the pieces. Now let's assemble them and look at your checklist for creating a killer blueprint for the Hangman game. Seriously, I want you to make this your mantra for this whole project. The algorithm is the blueprint, because if you have even a tiny crack in this foundation now, I promise you it will turn into a huge gaping hole later on when you're coding. If you get this plan perfect, the coding part is going to feel like a walk in the park. And just one more time, make sure you're using the official Nexa symbols. Ovals are for start and end. Parallelograms are for any time you're getting input or showing output, like getting a player's guess. Rectangles are for processes, doing stuff like calculations. And the most important one, the diamond, is for every single decision. Got it?
So here's your final check. Before you even think about handing this in, you need to be able to answer yes to these 3 questions. 1, can I draw this flowchart using all the right symbols? 2, have I used the correct loops and decision structures like while and if else? And 3, can I explain exactly how a function fits into my plan? If you can confidently say yes to all 3, then you've absolutely nailed this lesson. Look, all this hard work you're putting in now, on the plan, is going to pay off big time. It's going to make the actual coding so much smoother, faster, and honestly, a lot more fun. So your blueprint is designed, and I'll leave you with a little something to chew on. Once that perfect blueprint is done, what's the very first line of code you're going to write? Think about it, and we'll hit that next time. Now go get those blueprints perfect.